Hi, everyone. I am here on behalf of a secret society called Sidechains Are Not Layer 2. Just kidding. My name is Ali. I have been a contributor to the Ethereum ecosystem for some time now. Most recently, I have been working on something called Y Academy, which is an auditing collective aiming to scale the quality and the quantity of auditors in the space. I'm excited to be with this amazing panel talking about two of my favorite things, security and rollups. And I know Ed and Kelvin, you just spoke, but for the sake of people who are just tuning in, I would ask you, Ed and Kelvin, to introduce yourself and tell us also generally about, this is a security panel, so we're going to focus on that. So tell us exactly the current state of your system from a security point of view, current guardrails, your rollout plan, removing these guardrails, and generally like your philosophy around the security assumptions of your L2 or L3 if you are exploring that. Starting with you, Ed.
Okay. Is this on? Okay. So yeah, I'm Ed from Arbitrum. We rolled out our first fully featured mainnet product in August. From the beginning, we have had built in all of the technical affordances for security, including fully working and integrated fraud proofs. We have been working, we have a new upgrade called Nitro, which is coming up. So all of the parts are there for security and working. So let me talk about what the guardrails are. The centralization that still exists, which we have in place in order to be prudent about security and which we'll be taking off step by step. One of them is that currently we limit who can be a validator in the system, who can participate in the rollup protocol. That is permissioned and it will remain permissioned for some time. We'll be adding new parties to the permission set very soon, but eventually that will be permissionless. We currently run the sequencer. The sequencer is a centralized element. We'll be over time moving to a distributed sequencer so that if you K out of N trust those sequencer nodes that works, that provides the appropriate sequencing guarantee. The sequencer in our system is only trusted for sequencing and for nothing else. We currently have the ability to upgrade the software on L1 and L2, which we control, and we have the ability to do that quickly. We've retained that ability in order to be able to deal with any security incidents should they arise. And that's probably the most important remaining guardrail or point of centralization. We will be easing off that over time. And that means, first of all, separating ordinary upgrades from security emergency response, putting in place delays and community approval processes. The hard problem, which I think we're all wrestling with, is how to handle the possibility of security emergency upgrades.
Kelvin.
This is work. Oh, it's working. Yes, hi, Kelvin from the Optimism team. If you didn't just watch my talk. In general, I think we're all in sort of similar positions. The current state of optimism is quite interesting. We sort of went through this very aggressive upgrade in November that completely changed the back-end architecture. And so basically all the work that we had on our fault proof up until that point became completely useless. And so we started rebuilding it. This is this thing, Canon, that we've been working on. So at the moment that is not currently active on the Optimism mainnet. As far as the rest of this goes, the security assumptions are quite similar to what Ed was just saying. You have a single sequencer. You have sort of at the current a single sort of permissioned validator that can submit the results of transactions on layer 2. And of course, you have the same sort of multi-sig setup to upgrade contracts. Not on layer 2, we only have the ability to upgrade contracts on layer 1. But same idea, you have sort of instant upgrades on layer 1 with 6 of 9 multi-sig. So.
Thank you. We also have Patrick and Yoav, who are, have been writing or researching in the layer 2 space. So I'd ask you, actually, guys, to introduce yourself and then tell us, in your opinion, where are we now in terms of maturity? Are we at the stage where grandma can deposit, or how far are we? Starting with Yoav.
Hi. Yes, so I'm Yoav. I'm from Ethereum Foundation, and I've been researching security for Rollups and other layer 2s for a while. And I think, Rollups are certainly usable by now. So I wouldn't say it's like pre-alpha or something like that, but it certainly can't progress beyond beta as long as it's upgradable, as long as the layer 1 contracts are upgradable in any way other than with a delay by the community, because that's the consensus mechanism. So as long as the consensus can change without notice by a single entity, I would call it beta.
Patrick.
Yeah, hi, my name is Patrick. I've had a keen interest in layer 2 protocols for a very long time, going from payment channels to the Lightning Network to Plasma and now to Rollups. And I feel like there's 2 parallel tracks going on. There's obviously the Lightning Network on Bitcoin that we don't really talk about here. Then you have the Rollups on Ethereum that are basically creating the databases. And I feel like they're both very complementary, but right now they're very distinct in terms of their target audience. And I think in both cases, we're very much in the V1 world. So like last summer, I spent a lot of time looking at the Rollup projects, including Optimism, Arbitrum, ZK Sync, and Starkware. And I would call them all like V1 projects back then. They got it up and running, it was working. There's some quirks, some of them had to-dos in their comments, or in the code, sorry. But now we're moving on to the V2s where hopefully they're a bit more optimized and, actually nearly fully functional. But I still don't think your grandma should use it. It's more for the apes and the alphas and the Pepe the Frogs out there. I think that's our still target audience.
Thanks. So I would like to talk now about Rollup unique attack vectors. So in Rollup, we have the user wallet on one side, the L1 contract on the other side, and I think people are familiar with attacks on these 2. So someone signing a malicious transaction from a malicious front end resulting on their NFT being sent somewhere else. That's an attack on a wallet. On L1 as well, people are familiar with attacks in DeFi, for example, when you deposit into a vault, and then it gets flash loan attacked, and it gets drained. But then in Rollup, we have this thing in the middle called a sequencer or a prover. And I don't think people, thankfully, haven't had any major incidents against the sequencer in the middle. So my question next is to you, Yoav. You have written actually about this, and you actually uncovered some attack vectors against interactive fraud proofs. So I would like you to, without going into too much details, just give people a sense of what an attack against sequence might look like, and some of the implications like on other integrations with the Rollup and on some of the mitigations that you recommend.
Yes, so I recently published an article about some attack vectors I uncovered against optimistic rollups. It's not against the sequencer; it's actually against the rollup itself. I was looking into fraud proofs, and the attacks I demonstrated were due to the fact that there are 2 different implementations of code that runs the transactions on optimistic rollups. The normal flow is that the transaction gets executed on L2 on a node like Geth, and this is the happy path. But now, if the transaction gets challenged by a fraud proof, it needs to be re-executed somehow in an L1 contract. So that's a different implementation. And any difference between these 2 implementations can be exploited to create a malicious fraud proof where there shouldn't have been one, which allows you to roll back the chain by up to 7 days. This is the standard window. And such reorg, I mean, a reorg of 7 days can have disastrous effects. This was one kind of attacks, which I call it time travel attacks, because it allows you to travel back in time and change the history. And the other vector is an attack by a malicious sequencer, because since the attack needs, if the user, if someone submits a transaction, they expect certain behavior from the chain, and there are state transitions. But now, if you have a transaction like the one I demonstrated, which cannot be executed on layer 1, it executes fine on layer 2, but it cannot be simulated on layer 1 contract, then this transaction, then the sequencer can claim any post-state root for this transaction. So it can, for example, submit such transaction that's unrelated to the state change, and then include a state change saying that it minted itself 1 million ETH. And everyone will see the mint, but nobody will be able to dispute it. So now the sequencer has 1 million ETH more.
Yeah, because of the discrepancy between the transaction being executed in L2 and when it gets replayed on the fraud prover.
Because actually it cannot be replayed. It was a transaction that, due to a different implementation, there were some transactions that when you play with the gas, they cannot even be executed. The execution reverts in a way that's not probable.
Could you touch on the implication of this kind of attack on bridges, for example?
Mm-hmm. Yeah, so bridges, especially fast bridges, I mean, each rollup has a canonical bridge with a 7 days delay, but there are many projects, many bridge projects offering fast exits that for a fee, they are willing to give you the funds and let you exit in much less than 7 days, which means that they are taking the risk of a reorg. So let's say such bridge. So let's say I have funds in a rollup. I send them out, but before sending it out, I put a transaction that I can later dispute. After I withdraw the fund to L1, I dispute the transaction, roll the chain back, and now now I actually have the funds on both ends. So I doubled my money, and the bridge lost all of its money.
Yep. With apologies, I feel like I have to jump in here. These were not attacks against optimistic rollups, plural. These were attacks against a particular implementation from a particular provider.
Yes. I will clarify it.
Yes,
this is against.
I'm going to flitter.
Okay, I will let you off. It's against an old version, a single round interactive prover, which none of the optimistic rollups are using now.
Are using today.
Yeah, are using today.
Yes, it's against a past implementation.
Yeah, the idea here is just to give people a feeling of what these attacks might look like. Okay.
Yeah.
So you still have something to add, Yoav?
Yes, I wanted to. Then yes, I demonstrated these particular attacks against OVM1. This is an old implementation by Optimism, which is no longer in use. And I was going to explain that now both rollups are using interactive fraud proof. That Arbitrum was using interactive proofs from the start, and now Optimism is also switching to it. And with these, the attacks are much less likely, although I must say not impossible. It becomes much harder to do because the attack surface becomes much smaller. The state machine for the proof, instead of having the entire EVM execution flow with all the possible states, you only prove a single opcode. So it's a bunch of smaller state machines that you can prove. But since there are two implementations, in theory you could always have some difference. I have a few ideas, but I think it will be a bit too technical to jump into it now. We can discuss it later.
I mean, I think part of the takeaway here is that the security requirements for an optimistic rollup protocol are very subtle. And speaking from our experience, we have spent a lot of time working through what are the requirements and understanding what we need to provide and how to provide it.
Yes.
It's much more difficult than you might think, and I think all of the teams doing this have learned lessons over time in how to do that.
Yeah, the biggest lesson I would say here is that interactive fraud provers have a much less attack surface because it boils down to this single opcode replay on L1. So welcome, Alex, who just joined us from ZK Sync. And I ask you to also introduce yourself quickly. And my first question to you right after is something about called Trustless Liveness, which Ed was talking about just half an hour ago. And the idea is that a rollup user should be able to force their way out of the rollup in case the operator is malicious or down. And what Ed was saying is that ZK rollups might be challenged in this regard because it takes so much compute power to actually generate the exit proof. So what is your response to that?
Sure, really happy to answer. This is a great question. I'm Alex Glukowski, co-founder and CEO of Rollups. We are behind ZK Sync. We're building the first EVM-compatible ZK rollup, and it's live on testnet already. We have a specialized rollup for payments live on mainnet for 2 years, but of course, general purpose computation is a lot more interesting. We pay a lot of attention and dedication to the question of security and trustless security specifically, because we believe that rollups must inherit the philosophy of Ethereum of decentralized security, and users must keep their self-sovereignty at all times. And the way we solve that particular problem is we have a mechanism in ZK Sync version 2, which is called priority queue, where users can enforce their transactions from mainnet. So they can submit. It works a very similar way to how Arbitrum works. You can propose
I think we all do this, something like this.
Exactly.
Yes.
You can propose a block. You can include all the inputs of transactions in that block, including signatures, like whatever, what you would otherwise send to the sequencer. But you do it from layer 1, and you also pay your fees there for this exit on layer 1. And then so we do it for the full block, because you cannot just withdraw your funds from a rollup. You might have funds locked in some protocols as a liquidity provider in Uniswap and in other places. So you need to execute arbitrary transactions in order to exit. And so then we have this priority queue, and the operator or the group of the sequencer, which can be decentralized, and we will be decentralized with some consensus running in layer 2, has an obligation to execute the blocks from the priority queue at the next occasion. And if they don't do it within a very short time frame, then the rollup will enter in like emergency priority mode, where only the transactions from these blocks are allowed. Anyone can submit those blocks, anyone can provide the proofs, but their sequence of the transactions is predetermined. It's deterministic. So there is no race, like anyone can start building the blocks. And our assumption is that individual users should not do this, because your worst case scenario is that the sequencer became malicious. So there was this malicious takeover of the stake. More than the half of the 2/3 of the stake is controlled by some external party, which is malicious to the purposes of rollups. They start censoring users like selectively. And so the users want to exit in mass. So like if you're censored individually, you can always submit your individual transaction. That is not going to be expensive for you because it's just one transaction on Ethereum. But our worst case scenario is that mass of users, maybe some fraction, maybe a minority, or maybe even a majority of users get censored on layer 2. So for that case, what we envision is that those users will coordinate as a community. They will elect someone, or like someone will step out as a new leader, or like new set of validators. They will say, okay, we're going to make a fork of ZK Sync, and we're going to let the users mass exit to that fork. And they will submit the requests on behalf of those users en masse. And then the new set of validators, which will work in a very similar way in how the Ethereum would fork if there was a malicious takeover of the stake of Ethereum in proof of stake. So we would just like eliminate.
Alex, if I may interrupt, what if it's a single user that is being censored? What options does that have? What does the user have?
Oh, that's simple. They just provide their transaction in the they just submit a block of one, like the priority queue of one transaction, and then if the validator censor them, then the rollup will stop. Someone must process this transaction. So if the validators are so malicious that they don't want to process that entirely, they will not serve anyone else, but the user will have an ability to submit a proof, which is one for a block of one transaction, which is going to be very cheap.
A single case of censorship puts the whole system into that mode. Okay.
Yes.
Ed, you wanted to add something? Very quickly, please.
Very quickly, yeah. The other issue that I discussed earlier in my talk is the question of data availability. Do users or whoever is doing this emergency proof, do they have enough information about the current state of the system to do the proof?
Absolutely. So for the rollup, data availability is shared with on Ethereum, and to reconstruct the full state, you will spend less time than syncing full Ethereum full node.
I think what Ed was asking is, Zk rollups publish state diffs. Are those enough to reconstruct the state?
Sorry, Zk rollup?
They publish state diffs?
Yep.
Yeah, we will publish
to
specifically state diffs, which are easy to process. We're not publishing inputs for transactions like optimistic rollups, which you have to re-execute. We publish slot X gets the value Y. And then for the users, all you have to do is just apply this state on your database. You don't have to recompute hashes, you only do it at the end. So you can always do it for a Zk rollup with the same exact hardware requirements that are applied for Ethereum full node, which is like an ordinary laptop by design.
Okay. Switching now to a different topic, which is the issue of frameworks. So almost on a daily basis, we would have these arguments on crypto Twitter flaring up about this or that quote-unquote layer 2 solutions. Is it a rollup? Is it not? Etc. So we are not going into those debates now. But instead, I would like to know the personal opinion of maybe Patrick and Kelvin. How do you make sense of the security guarantees or security assumptions of a certain rollup? How do you personally determine how much security is rolled up in that rollup?
I can go first if you want. So the way I think about it is that there's this global database that has the account balances and the state of the program. And it's that database that we want to protect, because that really is like the outline of the liabilities for the system. And then on Ethereum, there's a bridge contract that holds all of the funds. So, there's some rollups of like $1 billion locked up and $3 billion locked up. And on a rollup, the way you can, not even a rollup, just for the bridge. So the bridge needs to be concerned about the security and the integrity and the liveness of this database. And so there's 3 questions that bridge is going to ask, How can you convince me as the bridge that all the data for that database is publicly available? So Rollups will just post that to Ethereum, and that's how the bridge gets convinced. You could have a challenge process, you could give it to a committee, give it to some data availability layer, but they're all different trade-offs, whether you're actually going to guarantee the data. But you have to convince the bridge of this. The second one's integrity. The bridge needs to be convinced for every single update applied to the database that is correct. So how do you convince the bridge to do that? That's the optimistic versus the ZK rollups. Historically, if it was something like Coinbase or, external trust assumptions, you're just relying on a third party to tell you that the database is okay. That's historically how those bridges worked. And then the last one's like this, what we've been talking about just now, is this trustless liveness or censorship resistance. So how can you convince the bridge that the database is being updated and that anyone can update the database? And so if you don't have a mechanism that allows Alice, who has a Mooncat, to transfer her Mooncat on the system, then it's clearly not censorship resistance. So my mental model is there's a bridge contract, has all the assets. It needs to be convinced that this database is okay before any funds can be withdrawn from the system. And so if you're not convincing the bridge, then obviously it's a trusted solution. So that's my mental model anyway.
Kelvin, what is your framework?
Cool. Yeah, I think what Patty says is absolutely a fantastic way of thinking about this. If you break down an optimistic rollup, or not even just any of these systems into sort of their absolute cores, you can kind of think of them as these state machines. And when you think of a state machine, you have a machine, right? You have a state transition function, you have some input state, and you have an output, right? That's a very simple construction. And so when you think about what properties you want from that construction, if you want, first of all, you want to verify that. If you want to verify the execution of this machine, you want to verify are the inputs to this machine accessible, right? If I don't have the inputs to this machine, let's talk about the optimistic case. If I don't have the inputs to this machine, I have a program, I don't know how to run it because I don't have the inputs. And so this is sort of the analogy for data availability. You need the inputs to be able to run the machine. And then the next step of this process is, well, the machine is running. How do you make sure that the machine ran correctly, right? You produced some outcome. And so this is like Patty said, the sort of integrity component. How do you guarantee that the actual outcome of running that machine is what was executed? And then at the end of this, the question is, how do you, the censorship resistance aspect is, how do you guarantee that users can continue to run the machine and that it doesn't just sort of arbitrarily halt? And so this framework, I mean, we're going to start to see these sort of boundaries between what's a layer 2 and what's not a layer 2 sort of fade away. The difference between, if let's say Optimism is publishing transactions to layer 1, and then Optimism starts publishing transactions to the EIP 4844 blobs, you've changed where the data is available. Okay, so now you say, well, is it available under the same security assumptions? And you say, oh, actually now, now the security assumptions have changed very slightly. Or if you go even further down into the sharding model, now your data availability operates under the assumption of a single honest party somewhere within the system that can sort of guarantee that the data is available. So it's just, you have this weird spectrum, and we sort of need to define the axes. But the reality is that I don't think it's possible to even, you want to define these axes and you kind of want to chart where people are on this multi-dimensional space, and it's hard to explain to people.
Yeah. For the sake of time, I want to cover as much as possible. So I want to ask about implementations. So typically we would want the system to be modularized. Major components are behind clean API so that you can upgrade or swap something without disrupting the rest. We agreed earlier, based on the discussion that Yoav was talking about, that it turned out that interactive fraud prover had less attack surface and proved to be the winning model. So I have a question related to this to you, Alex. I know that in ZK Sync, you have your approach is transpilation. So you go from solidity to intermediate and then you prove it. Compared to other approaches that have per opcode circuits, which arguably have a much smaller attack surface. Would you agree that that's the case? Is there, for example, another way to put it, is there a challenge for you in terms of attack surface that your pipeline is susceptible to any changes in Solidity compiler, for example? If it changes, you have to introduce changes to your pipeline, and that means new audits. Is that a challenge?
We don't see it this way. So with Solidity, we're using Solidity native compiler to produce the YUL bytecode. And then there is a very strict definition of each YUL opcode and what it has to do. So like there might be challenges, but they will come from different things. They will come from specific incompatibilities that we designed, that we decided that, yes, this operation or this precompile or this particular construct will work in a different way. So and this might lead, so like we have some changes, for example, around like we don't have native ETH, native token in the system, right? And this might lead to problems, but not at the opcode level, because those are invariants that are checked and guarded by compiler verification things. We have thousands, tens of thousands of tests covering like each individual case. Like those are very isolated and very modular and very easy to test in isolated environments. But the divergences, they could theoretically lead to like specific problems. But the great thing is our compiler will point out to those places where you're using something that is not, that diverges from Ethereum. So a really good example would be self-destruct. We deprecated self-destruct. We know that Ethereum is going down this way. There are a few EAPs that will be adopted, but like we just said, like it's such a bad thing. It causes so many problems on Ethereum today that we don't want to maintain it. It doesn't make sense, right? So like we just deprecated it. If you're using it in your code, it will still compile, but with a warning telling you like pay attention to this place. Like if it's critical for your functionality, you should reconsider.
If I could generalize the question a bit to everyone, basically, what parts of these systems do you think should ossify quickly, and do you think it's possible?
I guess let me answer from my point of view. And I can answer partly from experience, which are the parts of the system that have evolved less as we have iterated through versions and which more. The fraud prover is the part probably that is most stable, most heavily tested and audited, least likely to change. We have had, I think, 3 versions of our fraud prover, but within each version, there's been a lot of stability. So there are other components, for example, the sequencer. The sequencer has only limited trust in it, and parts of the node that have less trust in them tend to iterate more. It tends to be, I think because of engineering process, it tends to be inversely related to how much trust there is in that particular component.
Anyone want to follow up on this specific topic before I move on?
Yeah, I fully agree that the fraud prover is probably, it makes sense for the fraud prover to be sort of solidified because you can kind of think about it as a thing that plays a game, right? It plays this iterated game where you bisect an execution trace. That is a very abstract concept. And if you assume that we're going to play this iterated game, it doesn't matter what VM you're executing. If you can create a standardized interface for the virtual machine, you know, I think the long-term ideal is that you actually have multiple virtual machines or virtual machine implementations on chain. You have multiple binaries that you can run against these machines, and you have sort of this matrix of different options, and you can run all of them and sort of double check that these things are very, very correct. If you specify these interfaces well enough, you can totally do this like plug and play thing where you can always add new, L2 clients, right? We want to add clients beyond just Geth. We want to get like L2 Aragon, L2 Open Ethereum, right? The more client diversity we have, then like Yoav was saying, any difference in the execution between the client and the fraud prover will be easier to detect. So,
okay. One more question before we go to the audience. So if you have questions, get them ready. And that is about auditing. I'm wondering if you guys can give us a sense of what your experience has been so far getting audits, any particular challenges. Whoever wants to start first, maybe Ed?
Sure. I can't even count how many audits we've had on various components or parts of our code. To a first approximation, we buy as much high-quality audit as we can get. It's been incredibly valuable and useful, helping us understand where we stand, helping us understand how to reduce risk in how we structure the system and do engineering. A super valuable thing to do. Probably the biggest challenge is the tension between wanting to stick with audited code versus the need to evolve aspects of the system over time.
Anyone want to add to this? Alex, I'm curious, have you had any audits for your proving systems, things in the ZK part of the stack?
Absolutely. So we have one system which is live on mainnet, which has been most heavily audited on both the contract side and zero knowledge proof side, and we have specific documents describing the protocol in its entirety with all the invariants, all the guarantees that the protocol aims to make, and we demanded from the auditors that they analyze it from end to end, from the complete stack. This has been very helpful, but it's also been, I must say, that the community crowd sourcing of audits, looking for bugs, was equally helpful, and we really highly recommend using Immunify. Having you must have your own security bounty program. We have some requests submitted, so we they were mostly not critical, but they were very interesting for us really to learn. And I think no single security audit company can fully it's unlikely they will find everything. Okay. So this crowd approach was useful.
Yoav, you wanted to add something?
Yes, I wanted to add from the perspective of someone who audited this Rollups a bit. I think that it's more complex by like at least an order of magnitude from auditing any DeFi system. So I don't think it's practical for an auditing company to cover this in just a few weeks, to cover the complexity of a rollup, whether it's a ZK or an optimistic. So I think that I think there should be ongoing large bounties, which now there are, and I'm really glad about that. Because I think that the effort of ramping up as a security researcher, whether an auditing company or just a hacker attempting a bounty, since the complexity and the ramp up needed in order to learn how to work with such a system is so great that only a large bounty can attract people to it. So I'm glad to see it's happening now.
Just a quick question, just 5 seconds. How much do you guys think the number of auditors, qualified auditors, especially for the ZK proving system, should increase? How much of a shortage is there? Very quickly.
Well, you mean the ZK part, the circuits?
Yes.
It's constantly growing, and we're working with multiple research teams that have extensive experience in like not just reading proofs, but like writing inventing their own constructs, writing hashes, writing proof systems. Okay. There is no shortage.
So I'll open it up to the audience. If anybody has a question, go ahead. You're talking about sharding on layer 1. Yeah, I think that has been put in the back burner for now. So, but if someone wants to add something.
Well, with respect to data sharding, we can use as many shards as we want, right? Execution sharding, yeah, it seems to be backburnered.
Okay, another question?
Yeah, so I've been working on 4337, and it's not meant just for Ethereum mainnet. We expect that it will run on rollups. Initially, we are working on bundlers that run separately because it doesn't have to be part of the network because it's not a protocol change. But the long-term vision is that it should become part of the sequencer in all rollups. So I think sequencers should be bundlers.
Yep. I will also say really quickly that we played with account abstraction in the first version of the OVM, and we ran into enormous numbers of headaches. So I think no matter what we do, we will do it very carefully and make sure that we don't, gas estimation gets wonky and like the tooling's not, it takes a long time for sort of the infrastructure account abstraction to be ready. So we'll do it when it's ready, but we're not going to do it before then.
We would love to support account abstraction, and I think Yoav's playbook that he described is exactly what we hope happens. We would certainly be there. We would love to see a bundler in front and then eventually to work on integration into our sequencer. But we're not going to invent the wheel. We're not going to invent our own account abstraction mechanism.
Any more questions? Last question from the audience, maybe? Okay, I have a question about layer 3. Maybe to you, Patrick. Have you thought about this? What is true layer 3 to you?
Oh, I don't know. I always just see it as a big buzzword. No, I'm only joking. I think the basic premise is that there will be a bridge contract with the funds, and right now you have one chain basically. There's just one off-chain database. But the question is, can you take this database and this chain and build chains on top of it? So my understanding of the layer 3, and hopefully others could correct me if I'm wrong, is that you have a single database with the assets, and if you were to build more rollups or other off-chain systems on top of this rollup, you can just share the funds across them very quickly. So if I'm on like a hotel off-chain system and I want to move it to the train one, I can move the funds very quickly within this ecosystem. Okay. That's how I've always foreseen it. But maybe other people have a different opinion.
Kelvin, is Optimism exploring ideas around layer 3?
Yeah, I think this is an interesting design space. Everyone's kind of coming up with their own concepts for this. Optimism is most interested in this. We have this terrible name. We're calling it super chains. It's funny. But the idea is that you can construct a system that shares, that essentially you can have atomic transactions between multiple different chains. The magic of the optimistic rollup is that you do have this single block producer at any given time. And so if that single block producer can be scaled horizontally, you can imagine the single block producer be responsible for producing blocks on multiple networks at the same time. So you get these cross-chain transactions that are actually sort of atomic, and you can do these very weird things where you have different trust assumptions on different chains, and you can decide whether you want to interact with a contract on one of these other chains if you trust it or not. And yeah, so we don't have like a amazing specification for any of these things. We're not going to, right now, I don't think we're going to do the thing where we just put a rollup on a rollup. I think we'd rather get the sort of composability that you want. We don't love the multi-chain universe where you have to do all this complicated bridging between everything.
So you're thinking more of growing layer 2 horizontally as opposed to something like AnyChains or ZK Porter, which is Evolution. And actually, it's very interesting that Arbitrum has chosen AnyTrust, which has much different assumptions than ZK Porter. So could you guys touch on that?
Sure.
What is your thinking behind that?
Yeah, so AnyTrust chain, basically, the way we got to the design is we asked ourselves, what if, in addition to the rollup security assumptions, you were willing to trust, say, 2 out of 20 of some committee? How would the design change, and what could we do to drive down cost and drive down latency in that scenario? So not just like how to do external data availability, but if you're willing to make that trust assumption, what are all the gains you can get? And so that is an alternative strategy. It's not the only type of chain that might be an additional chain. I mean, I think if you're talking about L3s or a parallel L2s, I think there will be some of those, but the key to making that work for users is to understand the bridging and interoperation, and that requires very careful thinking about trust assumptions and what you can and can't guarantee.
Ed, if I may ask a specific question, do you think it's a fair criticism to say that AnyTrust is a premature optimization? Because it has a minority, honest minority assumption. Was that necessary? Why did you go with that?
As I said, the way we got there is we asked, if you're willing to make that trust assumption, then how could we change the design of the system to make it more efficient? So we started with the idea of external data availability, which others have done, right? You externalize data into some committee of data availability servers, and assuming that, say, 2 of 20 are honest, then you'll be fine. But we realized that once you're making that 2 of 20 trust assumption, you can do more. So it's not premature optimization. If anything, it's just a way of providing more efficiency for people who are willing to make an additional trust assumption.
Alex, I know that Volition has weaker trust assumption than AnyTrust. So what would you respond to?
These are 2 very interesting questions. So one is like ZK, Validium in general. So compared to something like AnyTrust, has very different assumptions because you never, the validators can never violate security of your funds. They can never corrupt the state. They can never execute anything that is not following the rules. They could just shut down the, freeze all the states, all of the funds, which will include their own stake, but they cannot steal funds. This is very, very important. This minimizes the incentive for attacker. Like, even if someone took over the hotkeys, like just hacked the system, they could not benefit directly. You can always negotiate with them. You can always tell them, look, we're going to put $1 million here, and if you just burn the system, you burn your own $1 million. It's a very different psychological game there. But that's just one aspect. A much more important aspect is the idea of layer 3 in general, and I think technically it looks like layer 3, but logically it just will look like a lot of layer 2s connected, put on the same root, put on the same basement, and this is the key idea to reach real mass adoption of blockchains. There is no way a monolithic public decentralized system can handle infinite load. They just won't work from the consensus perspective. Even if you had centralized servers running the sequencer, it's not possible. To get to millions of daily active users, like to reach out to, you're having cooperation with Reddit now with their community points, but they can only do it on a tiny fraction of their communities, because they cannot bring 500 million daily active users on a rollup. It just won't work. And that's just one example, like a tiny slice of all possible use cases, of all possible payments things. Like Alibaba handles like something like 140,000 transactions per second on a single day in China, where they have like huge sales volumes. So to get there, you need a bunch of those systems separated, running in parallel. And here comes a very important security nuance. It's only possible to have high throughput bridges, which are trustless, within a single family of the systems. And like my strong statement would be, and I'm turning into polemist right now, it's only possible with zero knowledge proofs, because you do not have, you cannot scale trust, you cannot extend trust beyond, based on game theoretical things, or incentivized actors, trusted actors, beyond one leap.
We are running out of time, so obviously the stakes are high, and Ethereum itself is reliant on having all these wonderful roll-up solutions mature and hopefully succeed. So in 5 years' time, we have an optimistic outlook from here and a pessimistic one. So optimistically, roll-ups continue to roll out, no major incidents, they ossify a bit, some innovation on layer 3. Pessimistically, we get hit with a series of catastrophic failure, which lead to insertion of trust in order to mitigate and deal with these emergencies. So I'm wondering, each one of you, very, very quickly, how optimistic are you? Where are you on that spectrum from pessimism to optimism in 5 years' time?
All of the world finance, trade, everything that has to do with transactions of value of any sort will be on blockchains within the next decade.
Patrick?
I mean, I'm incredibly bullish, but I think I'm bullish in the fact that I don't think users are going to care about it. I think it's going to be the operators, and hopefully they'll show up in my talk later. The operators can manage billions of dollars without having any custody of it. So those will be much more competitive compared to just every other Web2 service out there. So I don't see why we're going to.
I think we'll get to the point before too long where the capacity is available to serve whatever transactions their users decide should be on blockchains, that we'll be scaling out. There will be multiple chains using perhaps different technologies or different flavors of the same technology. But the capacity will be there, and we will have solved the interoperation problems to a satisfactory point where people can really use it.
Yoav, how optimistic are you?
Yeah, so I'm cautiously optimistic. I think that rollups are going to mature over time, and it increases capacity. It's it makes sense that everything will move there eventually. I think we will see a few catastrophes around bridges until then, but nothing that we can survive.
Okay, Kelvin?
Blockchains are a solved problem. It's just an engineering challenge. I'm highly optimistic. We'll scale. I mean, how can you not be? I don't know. Looking at just where things were 2-3 years ago, we didn't have a single one of these systems in production, and now we got this.
So finally, I'm hoping, just in closing, I'm hoping that this is also a peace summit. I know that in the past there has been some skirmishes between some of the rollups, and my rollup is better than yours, kind of thing. So what I'm going to do today, I'm going to ask some of you to say one nice thing about someone else, starting with you, Ed. So what I would like you to say, Ed, is something nice about something you appreciate about ZK rollups.
Sure. What I appreciate about ZK rollups is they're really pushing the boundary at trying to take exotic technology and reduce it to practice. That's a really difficult challenge, right? Exotic technology, it sounds like magic, but actually building it in a way that is reliable and building it in a way that is sufficiently efficient is a big challenge. And there's some super smart teams that are working very hard on that. It's exciting to see them trying to do this.
Alex, what is one thing you appreciate about the design and or implementation of optimistic rollup, whether Arbitrum or Optimism?
In my opinion, optimistic rollups are not much less complex than ZK rollups. They're just approaching this complexity from a different angle, and it's really exciting that they are live and they are operational now, and people can use it. Huge respect to you guys for having done that.
So Kelvin, finally, why do you think validity proofs are so awesome?
I think that the future of rollups is a hybrid optimistic ZK rollup. I don't think any other reality exists. I think we're all building the same thing. We just don't know it yet. And I think that it just makes complete sense. You get, optimistic trust in the worst case and ZK trust in the best case. So,
thank you to our panel. Please join me in thanking them.